Okay, so I stay here because the the recording stopped. So I was telling you that the mean of the sampling distribution equals the mean of the population as n gets larger, and the standard deviation of the sampling distribution will equal the standard deviation of the population divided by the sample size. Okay, so this is also called the standard error. Okay, now like I was telling you before, the formula will change now. If the formula before was C equals X minus the mean over sigma. So now, because we're talking about sampling, right? That will imply X bar, because we're talking about the sample mean, minus the mean of the sampling distribution, which is the same as this one will be like this, right? But since they're equal, you can just put the mean here, population mean, and then standard deviation is just sigma, but now it's going to be, we're talking about the sampling distribution, right? So it's going to be square root of, this is going to be the standard deviation divided by the square root of n, right? So that's where that formula comes from. Now, we have to use this formula depending on what's the question. I will show you how to do this. So here, they just explained to you that, right? That's just the same thing I just explained to you. This will be this, but now because the mean of the sampling distribution approaches the population mean is the same, and the standard deviation of the sampling distribution is the square sigma over square root of n, right? Now, let's see how we can use that formula, a new formula. So here let's say AC Nielsen report that children between the ages of 2 and 5 watch an average of 25 hours of television per week. Okay, so that's the average. So the random variable is normal anyway. And here is 25, that's the average per week. Assume that the variable is normally distributed and the standard deviation is 3 hours. If 20 children, now notice this, they give you a sample size, right? In the previous problems, they didn't give you that. They say just if a person or if something like that, but they didn't give you a sample size. So here you have a sample size, right? So that n equals to 20, right? Now, if 20 children between the ages of 2 and 5 are randomly selected, find the probability that the mean of the number of hours they watch television will be greater than, okay, so they're asking you for the mean, should be greater than 26.3 hours. So here you can do it right away. X bar less or equal than 26.3, right? So this is equal to 1 minus, we have to use the sampling distribution or the central limit theorem in this case, X minus mean sigma over square root of n less or equal than 26.3 minus the mean of the population, 25, over the standard deviation, which is 3, over the sample size, which is 20. Okay, so now this is 1 minus the probability of C, less or equal than, so now we need to find out what is this, right? This number. So 26.3 minus 25, 3 divided by square root of 20, this one divided by this one, and you get 1.94. So we need to look for this value, and we need to subtract 1 from that. So what is the C value less than 1.94? So let's look at the table, 1.94, and then we're done. 1.94. Here, 1.94. 97.38. So 97.38. You look for that value, 1 minus 1.9738. It's going to be small, right? So 0.0262 or 2.62%, right? So that's the answer. What is the probability that the mean of the number of hours they watch television will be greater than 26.3 hours? Almost 2%, right? So you can see the same, 2%. So that's when you use the central limit theorem. Here they give you another one. The average age. Let me do one that is okay, mix both. Okay, so you can understand better this stuff. Yeah, this one, perfect. The average number of pounds of meat that a person consumes per year, so is 218.4, and assume that the standard deviation is 25 pounds, and the distribution is approximately normal. Okay, find the probability that a person selected at random, one person selected at random, consumes less than 224, right? Pounds per year. So now you have to the area to the left. So I just need to do this formula, the old formula, right? 218.4 minus, I'm sorry, 224 minus 218.4 over sigma, which is 25. And once I find that, I find my area and I'm done. 224. I get 0.22. So what is 0.22? I look at the area and that's it. I'm done. 0.22. 0.22. 0.22 is this one. Is 58.71. 58. 0.5871. So I'm done with that question. Okay. The probability is 58% or 58.71%. Okay. So that's right here. Now, this is another question. Same problem. Same normally distributed to 18.4 and 25 pounds. Now, if a sample of 40, do you see the difference between the question from before? The sample of 40, here they were asking only find the probability that one person, right? Here, 40, and it's 40, it's different, right? And just in case this formula, the central limit theorem formula, works for all problems. So let's say you get confused between which formula to use, you can always use the central limit theorem, right? Okay, because let's say if you use the central limit theorem here, you will put, I mean, technically it's not correct, but you will end up with the right answer anyway. So, but try to understand what's the difference between these two, okay? Now, since we have a sample of 40, yeah, so you can just find what they're asking. Find the probability that the sample will be less than 224 pounds. So now we have to do the central limit theorem, x minus the mean, sigma over square root of n, and then 218.4 minus 224. Standard deviation is 25, the sample size is 40, and then we're done, right? So this is C, and we need to subtract that. We're gonna get a negative value, 218.4 minus 224, 25 divided by square root of 40. This one divided by this one is negative 1.42. We look at the table and then we're done, negative 1.42. Negative 1.42. Negative 1.42, that I think it should be here. No, not actually there, it's here, this one. This one. So it's 0.0778. 0.0778 or 7.78%. Right? Less than 224. Okay, let me double check if because I see that they have something else. Did I calculate this wrong? Let's see. 218. The average is 218. 25 is the standard deviation. They're asking for 40. Yeah, so it should be the mean. The mean x, the x minus the mean, which is 220. Ah, okay, I know what I did wrong. I did it backwards. This is 224, I'm sorry. This is 224, and this is supposed to be 218.4. I'm sorry about that. Okay, and now you're gonna get positive, right? So you need to look for 1.42. That's the only mistake. So 1.42, look at the table, instead of, well, there should be some symmetry here, 1.42, but anyway, let's look at this, 1.42, that the answer is 0.9222. So this is gonna be 0.9232, 0.9222. 22? Yeah, okay. So be careful when you're doing these silly things, like you can make mistake, right? But anyway, make sure that you understand that this is the mean, right? And this is the standard deviation, right? So in this case, the mean was 218 and the standard deviation is 25. And if these are given, right, then you can use the table. Okay, in another video, I will record a continuity correction, okay? But let's leave it here for now. Thank you.